Welcome to solverfy.
Usually I draw pictures in advance, but since 22 asked to use the technique of a ray diagram, I feel like it might not be a bad chance to actually go through it. So we want to show that the magnitude of magnification of a concave mirror is less than 1 if the object is beyond the center of curvature, and is greater than 1 if it is within the center of curvature. Well, let's get to it. So the first case is going to be where the object is within. So we have our mirror. Focal point is here. And center of curvature is equal to 2 times f. So there. Oh yeah, center of curvature is just the radius. Don't let them trick you. So we're going to put our object distance here. And let's trace some rays. So the first one is going to be parallel. Hits here, and it's going to go through the focal point. And let's just have it go off quite far so that we can intersect it at some point. And then the second ray, let's send it through the focal point, and that is going to come out parallel. So it is going to go this way. And thus the image that is formed is, of course, inverted and greater than the original object, because this one is obviously bigger than the other. So the height, not including the sine, is going to be greater than the height of the object. Thus the magnification is over 1. Well, let's look at the other case where, and I'm terrible at these half circles. Here's the focal point, sorry. Here's the center of curvature. And we want to put the object outside of the center of curvature. So put it there. Actually, let's make it a little taller so that we can get clean lines. So the first one we will do is going to be parallel. I feel dashes are going to be simpler for everything. And the parallel line comes in and then goes out through focal point. This is much easier to do with a ruler, by the way. And then finally, we have a line that comes through the focal point, hits here, and then let's have it come out parallel. Oh, cutting it close there. And that is yeah, I'll say it's a little smaller. You know, imagine I was doing this with perfect measurements, but thus yeah, it's hard. It's really hard to say on this one, but the image is certainly a little bit less than the object. Thus, the magnification is, well, yeah, also we should say the scale here is less than 1. But on to something that is a little bit less dependent on our drawing skills is going to be to use the Lens equation, or sorry, the mirror equation. And we want to solve for the magnification eventually. But let's go ahead and take this in turn. So 1 over d object plus 1 over d image is equal to 1 over focal length, or that's equal to 2 over r because of this. And our image distance is going to be related to RDO, our object distance, divided by 2DO minus R. And we'll also take a look at the magnification already, which is just minus R over 2DO minus R. Okay, so if our DO is greater than R, then that is like case number 2 over here. If we look at our equation for the magnification, let me clear this up slightly. This is, in fact, a minus sign. Then 2 times, also I've switched to using big R, which is strange. But 2 times DO, if it's bigger than R, minus R, is going to give you a magnification that is certainly less than 1, because the thing on the bottom is going to be bigger than the thing on the top. So you can write it like something like this. Something greater than R. And finally, there's the case where if you're between R, or if you were between the focal point, which since we want real images, we should be between, should be greater than the focal point. If we are located in that sweet spot between 1/2 the radius and DO is less than R, then 2DO minus R is going to be less than R. So M is going to be greater than 1, because just like over here, you have an R divided by something less than R, which will lead to something being greater than 1. So I recommend you go through that. Don't worry about the sign so much, because we're just looking at the magnitudes. But go through that to make sure that both of these arguments make sense.